I'm thrilled to be speaking with you here today, because what you're learning about or already practitioners in is the key to the next wave of AI. It's absolutely, and we are starting to hit hard boundaries of the opportunities presented by large language models. When I was asked kindly by Benoit and Zach and Lulit to talk, I thought very carefully about what could I say that would be of interest, because I'm constantly learning myself. And one aspect that I think that is still underrepresented across the broader world around the opportunity is really how we combine the semantic layer with large language models. I also wanted to be a little controversial, and I hope I'm controversial enough, because talking at a lot of conferences as I do, there are many, unlike this, I would say, that are echo chambers, where a lot of people in the data management and analytics and AI industry are saying the same thing and not really challenging people. So hats off to EK, particularly Malcolm Hawker is somebody I massively admire, who spoke last year, because he does challenge the status quo. So a little bit about me and why I'm even talking. So I'm Chief Data Officer and partner at Orteca. We are a data analytics and AI consultancy, but primarily I'm a father and a husband, and I describe myself as an endurance cyclist because although I like to cycle, I will never win any race. I certainly know how to suffer. But yeah, I've held some interesting roles. I was the head of information architecture at BT Group, a large digital services and telecommunications company in 180 countries around the world. I was the global head of business data architecture at HSBC and the global head of governance for their financial intelligence unit. I've held a lot of global head roles, and I think I put it down to the fact that my head is sort of globe-shaped. But no, I'm a big user of data in those roles, as you can imagine. So, and I was a data architect, a mechanical engineer. I was mucking around with machine learning back in 1998, back when they were backpropagation neural networks, and I was fascinated by them. So I've continually been using data in different guises, and I like to talk at lots of conferences. And I'm not being paid today, just as Zach said, but I do enjoy the free coffee. So enterprises are built as silos. I want to sort of share with you some of the psychology, perhaps, of why we got into the space that we currently are, and why, for example, data management as a discipline has been trying to, and knowledge management is trying to unify the way enterprises work, and what really got us into this mess. Also, how we can solve it, because it's not just humans that are now suffering from a lack of information structured in the way that they need, but it's now very obvious that AI is suffering as well. So I want to call on an analogy, which is the QWERTY typewriter layout for your keyboard. Now, you may be familiar that this is an old invention, but were you aware it's 1878? This is how long ago. This was created specifically to stop the mechanical hammers in a typewriter from jamming if you could type faster than it could cope. So we've actually been, my laptop here, I'm sure most people's laptops still use that standard, and yet there are no mechanical hammers that need to be slowed down. In fact, if anything, we'd like to be able to type a little faster. And yet, new standards haven't been adopted, and there are new standards out there. So why is that? And what can we learn from that in terms of the way that we're treating data? So we have a challenge associated with how data has been structured historically. And I'd like to, this is not the only challenge that we have. But when I was a data architect way back in 2007, I'd be designing relational databases. And I'd be asked to design a relational database for a particular set of functionality. It's not like, Ben, we know we'd like you to create the CRM database, but we want you to keep in mind the needs of data for the entire organization. Nobody ever asked me that. They said, we've got a CRM database. I want you to structure it in the most efficient way possible. And often, in those days, that would mean entity relationship diagrams that I would design, and then they would be handed to a DBA. And this is the Microsoft Northwind database, just to illustrate that point. Now, apologies if you're familiar with these ideas. If you are, that's great. Hopefully, this will be new ways of communicating in a powerful way or an alternate way. But if you're not, this is really important that you understand how this has really limited our ability to be able to draw knowledge and information from these things. So I'm not against relational databases. They have a place. But we do need to be aware of the limitations that they've imposed upon us. So first of all, when I was designing my little CRM database, for example, I would be having a little siloed worldview of how a CRM database might work, and not really thinking about how the rest of the enterprise might use that data, as I illustrated earlier. That goes for any system you buy or build. Because unless you're educating those database designers to think in the broader enterprise way, perhaps, with a semantic layer, then actually there are problems. So that means that you've got an integration industry that is endlessly trying to reconcile systems built on small siloed worldviews. The other aspect is third normal form, and I don't expect everybody to be familiar with this, but the way that these are structured, and I'll illustrate it further later on, mean that you actually have to invent things between tables to allow a many-to-many relationship. So what we can see here is customers might have many demographic capabilities, one-to-many in terms of the tags. But demographics may have many customers. So we have this customer-customer demo thing that's not real, that's introduced. And the same goes for employee territories. These aren't real constructs, but we're having to fudge these into databases. The other thing is, if you look at things like suppliers here, they all seem like reasonable entities until you dig into them. A supplier is a supplier of services, is a supplier of products. It seems it's only products. And so if you were to try and use the same type of construct for services, would that be challenging? The other thing is it's a one-to-many relationship. So say you're selling oranges. You can only have one supplier of oranges, according to this, which is an interesting construct. Then the models themselves are separate from the data. And actually, with a knowledge graph, the conceptual model, the schemas, are obviously closely aligned. So you're endlessly trying to update models based on reality and based on how your organization is actually implementing these things, and keeping those in tandem is really hard. It's got complex change management, including the need to take down SQL databases to be able to deploy them. So that actually creates a bit of a brittle and a non-iterative approach. People say, well, we can't really even start on this until the entire data model is known. Well, there are better ways than that, of course. But of course, that creates a more brittle way of working and an inability to innovate and iterate. The other aspect is the meaning is separate from the instantiation. So you have to have separate data dictionaries, data catalogs, and all this kind of stuff. You don't have things like RDFS comment to be able to describe what you mean. So, and then the other aspect, lack of portability. So if you've ever tried to move a SQL database from one instance to another, it's a nightmare, and you often have to pay these large service integrator organizations to do this. And vendors love that, because that locks you in. You have to keep paying your license to them. Whereas actually, if you're using common standards like RDFS, and in fact, there was some fantastic examples from Lulit yesterday in terms of taking 2 weeks to move a giant graph database rather than the many months it would take. You have the ability to be able to move easily and reduce vendor lock-in. So, bit of a controversial one, but I do stand by this. Trying to describe an enterprise using a relational database is like trying to tell a story, but not allowing verbs. And this, in a bit of fun, this is Jane Austen, the famous author of Emma, and this is an AI-generated, miffed Jane Austen when you've removed all the verbs from her masterpiece. So the point being, when I would design and I'll show you this later, when I designed a database, in fact, let's quickly jump back to this. A supplier supplies products. When I designed those databases, I'd write in the verbs, and I'd hand them merrily to a database administrator, who would then remove the verbs and say, there's a primary key here, it's a foreign key here. And of course, that meant that all the context associated with what really I meant by all of these things and their interactions was completely removed. And that is a problem, not just for Jane Austen, but actually it's more of a problem for AI. And we're going to talk about how AI gets tripped up as we go along. Now, I do love a good quote, and Charlie Munger, the famous investor, used to say, and I use this everywhere, you show me the incentives and I'll show you the outcomes. Those vendors who love to lock you into their ecosystems absolutely love the lack of portability here. And in fact, graph database providers who stick to common standards often actually suffer from that portability, but they do it because they care about their customers' outcomes. They're not trying to lock you into some... So be very careful of the organizations that are talking about semantics, but aren't thinking standards, because there's a huge wave of new semantic layers and semantic... There were some fabulous descriptions of metric layers, really, rather than semantic layers yesterday. And so do be cautious of those incentives. We need to be embracing things that actually help our industry and our customers primarily. The other thing is, why have we not adopted QWERTY, for example, evolved beyond QWERTY? Well, look, if I've invested all the time to do touch typing, or on a QWERTY keyboard, getting a new keyboard just seems like a real pain. And also, I've got my special certificate from X touch typing course, but which I haven't, by the way. I'm appalling at typing. But the point being, with SQL databases, is exactly the same. The industry is familiar with relational databases, and they get a little threatened sometimes associated with that. I mean, I was always designing entity relationship diagrams myself. I was super proud of how I could think in third normal form. But what I would say is, AI doesn't care what you're comfortable with. AI is going to demand we use whatever works best. And when Darwin was talking about survival of the fittest, it was fittest for the environment. It was actually that flexibility, the ability to learn new skills, to adapt. And what I would suggest is it is really important we challenge ourselves and our colleagues to evolve, to continually be relevant. If we're still using old technologies, and relational databases are older than me. I'm turning 50 next year, and they're actually older than me, early 1970s. And we're not going to be able to get rid of them anytime soon, by the way, and nor should we, perhaps, because they're very good in terms of transactional and operational systems. But what can we do to do something a little smarter? Now, I was really pleased that Zach mentioned this report. I would really recommend looking into that. The MIT report, 95% is damning, associated with the incredible amount of money that's been wasted in this space. People have learned a lot, but they're all learning the same lessons independently, and many of them, including Nobel laureates, have not really woken up to the fact that LLMs are actually inherently limited. I worked that out in 1998 when I was in a bunker underneath Bristol University using a very simple machine learning, because it inherently hallucinates. And actually, it will hallucinate bad things, of course, on bad data. But hallucination is something that's inherent in machine learning. And actually, if tempered correctly, is a benefit, not a problem. But it has to be dealt with from a creative perspective. So I'm going to show you some analogies that hopefully will bring that to life. But when we look at Gartner, for example, among the top 6 barriers to adoption from their 2023 survey, it was a lack of trust in data and a lack of trust in AI in general, which is we've all experienced, I'm sure, and a lack of data. So the other thing is, I want to challenge you associated with how we even think of AI at all. Because everybody wants AI to be very human, of course, act like a human. We want it to be able to, answer every question accurately, just like a human. Be able to do everything possible and imaginable all as one thing, just like a human. Well, perhaps not like a human at all. If you've watched Lawnmower Man, again, I'm aging myself somewhat, it's a dangerous thing to concentrate all of the skills and knowledge and activities into one thing, to quote Zach. In fact, you wouldn't want a team to run your organization like that. Well, we're getting rid of everybody. We're going to replace them with Bob. Bob is all-knowing, all-capable, and therefore, we wouldn't have lots of single-person risk there in case Bob was compromised in some way or disgruntled. Nobody would do that. Also, who could afford Bob? In fact, an agentic approach is much, much smarter in terms of flexibility, but also managing risk. We set up teams of specialists with people. Why would we not do exactly the same with AI? And actually, that is genuinely the network effect that I think we'll see as an incredible opportunity. Speaking with Bob Metcalfe, with Paco and others in New York earlier in the year, and Metcalfe's law talks about the network effect, or the value of a network, and actually, if you have a network of agents, the sky really is the limit. So incredible opportunity if we're thinking in that way, rather than just one all-encompassing AI. However, things like MCP, which I'm a huge fan of, so don't get me wrong, have not learnt, sadly, and I don't know what it is about AI, but we seem to just throw away the past, like, we don't need to learn anything from. So MCP has kind of thrown away more than 40 years worth of robotic process automation learning, and you actually have to build on top of MCP to make it as effective as possible. So when we look at all of these attempts at automation, I really think it's so sad to some degree that we aren't building. I mean, increasingly I sound like a grumpy old man. But at what point are we going to wake up and go, do you know what, we learned some stuff, why don't we use that now? So when we see MCP and Agentic AI, and I feel like Magatu in Zoolander, that realized that Zoolander only really had one look. How are we going to do this? Because, of course, we have been here before. The paperclip that was telling me that I was writing some kind of letter and could it help? There is a real danger that we fall into something that is fairly limited in its ability. And also, there's a beautiful article, which I'm very happy to share with anybody who connects, which I didn't write, but I've valued, associated with the shortcomings of MCP. I really think MCP is in the future, by the way. I do think that there's incredible opportunities, but it's very immature. So here's a little bit. I won't go through all of them, but actually, there's aspects associated with session management that you need to build around, for example, to ensure that there isn't data leakage between one agent and another. There's the cost aspects in terms of almost, handing the equivalent of a new employee the company credit card and go, can you do some stuff for me with all of these things, and try not to spend too much without giving any kind of limits. That's effectively how we're treating MCP. The other aspect, of course, is how are we limiting the agent's access to data to the data it needs for the purpose, like we would with a person, one would hope, because there is a huge spate of cyber attacks, and if we think it's bad now, it's going to get a lot worse as geopolitical unrest unravels. We absolutely have to be locking down least privilege, zero trust around data, and if we're not doing that with our agents, you can imagine the havoc that's going to happen. And there is nothing in built-in MCP that does that, so it's on you. The most important thing, of course, we're here about semantic layers, and semantic layers can unlock a huge benefit associated with locking down that least privilege and other aspects, and also ensuring that when an agent is traversing systems on your behalf, and they're totally different data models, remember little Ben and his CRM system back in the day, it's going to try and work out, without the ability to reason or infer, because it can't, no matter what they say, it's still, unless it's augmented with semantic layers, they can't properly reason or infer because they don't understand meaning. So it's going to try and work out what those schemas mean, and it can't do it effectively unless we're supplementing it. So a better premise. Now, this is a slide used. My dear friend Sean Rolls from Closed Circle lets me use this. But what I love about it is the richness of the context of data is incredibly important if we and knowledge is incredibly important if we're going to get greater benefit. And we need to be thinking beyond old structures, or at least augmenting them, to be able to do smarter things. And my dear friends Juan Cicada and Dean Alamain, Data.World, now ServiceNow, there was some talk about that yesterday as well, they've released these fantastic white papers. They are actually benchmark reports. So they established a benchmark that said, we think, this is a few years back now, and this is how Neuro-Symbolic really sort of has been quantified most accurately, I feel. A relational database from OMG of insurance claims. Sounds not terribly exciting, perhaps, but effectively then asked a series of questions of varying complexity based on the number of tables it would need to use or the complexity of the calculation, and asked a large language model just straight on the SQL database, just passing a DDL, the description of the database directly, and another one where they'd done a very small amount of semantic modeling on the top. I would actually say, in a longer talk, I could show you but it's about 10 minutes worth of modeling. It was almost trivial. And they demonstrated a 400% increase with a small amount of error checking associated with that, in the second white paper, that is, off doing that very, very small amount of semantics on top of an existing SQL relational database. So mindful that we aren't going to be able to get rid of SQL databases anytime soon, and mindful that we probably shouldn't. And there are many other different serializations of data and structures of data anyway that we need to embrace. This quantifiably demonstrates the benefits of semantics. And it's a repeatable benchmark. It's deliberately simple, and it's one that you can use with almost any LLM. So I would, this is, I'm not going to show you the video, of course, but this is at the Turing Institute. This is Juan delivering that talk, and you can actually get it weirdly through GitHub. There's a link that you have to get through the Turing Institute's special interest group, but I would recommend listening to that if you have time. So the other aspect is I spend a lot of time teaching people about data management and data catalogs, and data catalogs are really struggling. And I would say a lot of that is because they have limited their view. They're not thinking like EK in terms of semantics. Everybody knows what a list is. A list with a definition is a glossary with a structure, maybe nested lists, or an org chart like parent hierarchy is a taxonomy. When you start to add the richness of relationships and constraints, you start to get something so much more powerful on top of that. And life is multidimensional. So when I join an organization that's trying to implement a list-based data catalog, and people are arguing whether the billing address is in the billing list or the address list, I go, oh dear God, what a waste of energy, what a waste of life. The world is not a series of lists. It's a very useful construct if it's working for us, but not if we're constraining ourselves into that's as far as it goes, folks. We're a data catalog. We don't do the stuff that really reflects the way the world works, an ontology, a mind map, if you will. And when you add in data to that, you get yourself a knowledge graph. And you're with experts in that, with EK. So I love this quote. Knowledge is knowing that a tomato is a fruit. That's a classification. Knowing how to use it is wisdom, according to Miles Kingston. And I like that. So I have a silly example here, but you've got a glossary on the left-hand side. You've got a taxonomy of fruit. It's not a terribly rigorous taxonomy. You've got Solanum here, which is a genus, and various colloquial uses. But interestingly, aubergine is a fruit as well. I learned that when I was doing this a few years back. Again, you probably wouldn't put that into, well, not a fruit salad for sure, unless maybe Heston Blumenthal and some great food innovator might. What I've done cheekily is basically do almost a hierarchical ontology here. But we've got Ben's fruit salad. And one of the things I really like about ontologies is you can actually say, here's the structure of the data in terms of domains and subdomains, but here's the use. And a lot of data management professionals really struggle with communicating who's using their data for what purpose. And so actually ontologies is a natural way of doing this. I'm mindful that many of you work in graph and are familiar with this, but hopefully this is useful. Obviously, subject, predicate, object is a triple, how these things are structured. But if you wanted to sort of get going very quickly, you can start to almost create a mind map of ideas. So we've got Ben, Ted, and Susie, and we've got trifecta sushi, Zen air noodles, and Japanese food. And the idea really being, and this is very loosely based as an example on friend of a friend, you've got Ben is a friend of Ted, Ben is a friend of Susie, Ted likes trifecta sushi, which serves Japanese cuisine, Susie likes Zen air noodles, which serves Japanese food. So this is, of course, how social networks work, and the idea really being, of course, both Susie and Ted have explicitly stated that they like this food, but by virtue of the fact that Ben is a friend of them, he may be slightly more predisposed by a small percentage to be more receptive to adverts for Japanese food, or Japanese restaurants, of course. So you can start to infer things associated with this. And of course, this blends individuals with classes. And so actually, if we take a step back, having done that quick mind map, we can say, well, look, Ben, Ted, and Susie are instances of a class person. And of course, Japanese food is a type of cuisine. And Zen air noodles and trifecta sushi are types of restaurants. So effectively, we've created effectively a class semantic model as simple as this. And look, that might not be where you end, of course, because of course a person might like a cuisine, but don't like a restaurant yet. So you can start to do really cool things. And it's so simple, of course. So one of the things I really love about this is that you can teach anyone to draw a mind map. In fact, good old Tony Pazan, who helped sort of champion mind maps around the world, it's now used in so many educational settings that most people are familiar with designing those. If they can do that, they can really start the beginning of a good ontology. Not to say you don't need a skilled ontologist to take it the last mile. Of course you do. But I'm a big believer that we should be helping organizations do this at scale. There's a wonderful phrase called ontological shock. It's actually a psychological phrase. And it's meant to mean that when somebody's worldview changes so dramatically, and I think it's the equivalent of maybe, suddenly being plunged into a wartime setting, or taking psilocybin, or realizing that aliens are real, or something along these hypothetical lines, that it changes somebody's mental model of the world so rapidly that that's a shocking incident, something that needs help. What I love about the phrase, more than sort of slightly strange examples, is that it implies we all have an ontology. They say everybody has a book in them. Well, I reckon everybody is an ontologist, and so they just don't know it. So actually, when you're looking across an enterprise, they're all graph-like structures. They're all networks. And so when we're doing data management, it's really important we think about, how can we structure that? So you remember when I said hallucination is actually a blessing, not a curse, if it's handled in the correct way? Well, there is a very simplified model of the brain, which effectively thinks of one hemisphere as being more creative and the other hemisphere as being more logic and reasoning and fact-based. And actually, the construct of Neuro-Symbolic AI combines the two. So if we were too creative, we wouldn't be able to function in society if we were hallucinating all the time and thinking up wild ideas and not actually having any kind of bearing in terms of relevance and conforming at least partly to society. So of course, the great thing is we also have a construct of the world, of facts, of how they interrelate, of how we can use those. And good old Ian McGilchrist, who I'm a huge fan of, if you're into this kind of thing, has written some incredible books. He goes way beyond the simplification that I have here, but effectively of how we've been too left-brained for too long. Now, but however, we definitely need to be able to combine these modalities in our AI if it's going to mirror the way that we need. So that hallucinatory creative aspect that riffs on old ideas and comes up with new things absolutely benefits from being tempered with a knowledge graph. And of course, if you're building your enterprise and your enterprise domain knowledge as a graph, use case by use case, of course, and, you don't want to boil the ocean, but you do want to do it bit by bit, then you're actually building that aspect of the Neuro-Symbolic AI by default from the data management and the analytics use cases that you're building out. You combine that with large language models. So, as I love a good quote, this is actually my favorite quote ever, George Bernard Shaw. The reasonable person adapts themselves to the world. The unreasonable one persists in trying to adapt the world to themselves. Therefore, all progress depends on the unreasonable person. So I'd love to ask you, how unreasonable do you think you should be? We can't change those SQL databases, but we can overlay some really sensible and smart ways of working. Okay, so I hope I'm going to be a little controversial here, because I haven't written an MIT report on how many people have moved data to warehouses or the cloud. But I would say also it's probably a comparable percentage of them have horribly failed. and why do I think I have a reasonable view on this? I teach cloud data management capabilities for the EDM Association. And I help write those. And initially they said, well, okay, we think that we need a standard for moving data to the cloud and managing it well, because there doesn't seem to be one. And so my friends Ollie Beige and Richard Paris went to the EDM Association and said, well, maybe we can do something smart to write this. And they thought only 20 people approximately would turn up. Well, 300 people turned up from 100 companies around the world and built a standard associated with good data management. And ostensibly, that's because many of them had found that they'd rushed the data into warehouses, cloud environments, etc., before it was ready. And then maybe they hadn't, but they've inherited it, or all sorts of things. And of course, why would that be? Well, the incentive for the warehouse people back in the day, in the 80s and 90s, and the cloud providers, as much as I love the cloud providers, by the way, their incentive is to get your data onto their cloud as quickly as possible so they can start charging you for it. And I don't blame them for it. But again, is that the customer or the vendor that's benefiting there? A bit like my Charlie Munger incentivization thing. So here is a very simplified view of a three-tier architecture. I've used the same kind of medallion language that Databricks has championed with bronze, silver, and gold. And a lot of the time, people, they go, okay, well, first of all, we've just got to move all the data into the cloud. Let's move it to bronze. We can pay a huge service integrator consultancy to move this for us. They've done it before. Doesn't mean they did it well, by the way. But they've done it before. And then what we'll do is then we'll conform it a bit around maybe domains or subdomains if we're being super smart. And then we'll turn it into use case-driven analytic type of consumer-aligned products. And then finally, we'll get to the benefit. The problem is, a lot of the time, they lose momentum halfway through and lose money. And again, I'm going to age myself, but if anybody remembers the Kevin Costner film, The Field of Dreams, it was a very charming film. It was Kevin Costner was a farmer somewhere out in Middle America, and he had a cornfield, etc. And the voices in his head told him that he needed to build a baseball field in the middle of nowhere. And he not unreasonably, said, well, that's balmy. Nobody's going to come. And they said, build it, and they will come. Wonderful story. It's absolute nonsense, but charming nonetheless. And maybe it is the fact it's nonsense that's so charming. Unfortunately, everybody's moving all of their data without thinking about it straight into the bronze layer, is reliving the field of dreams. They're building it on the basis that somebody might use it. And they don't know. They really don't know at that stage. And that's, why do they do that? Well, because they're still stuck in SQL relational database thinking. We need the whole data model. We need all the data before we can work out what we do. They can't think iteratively because they're still stuck in QWERTY world. So is there a better way? I mean, first of all, this is how EK works, for example. Work on the use cases. Understand what you need. and then actually pull the data from this side. It's not a push. Let's not amass all sorts of data unnecessarily at great cost and start paying for the supermarket before we started selling anything. Let's actually pull it from the right. And so I'm a big advocate of the same type of methodology. So if I was going to, do a very quick analytic use case on that right-hand side, I would do something along the lines of, let's build a semantic model. I mean, and you can build that semantic model through the taxonomy pipeline that was beautifully described yesterday. If anybody gets the opportunity to go to the workshop next year that was held yesterday, it really is time well invested. And really, this is a gross simplification of a parallel or similar complementary approach. So you take a semantic model. You can actually throw those ontologies straight into a large language model and say, given this turtle ontology, please create me some synthetic data that I can test with, which is a really quick way of testing the validity of the model. You can ask some questions of it, and you can ask questions using the large language model as well, saying, given this ontology, I want to write a Sparkle query that answers this question. Does it answer it? No. Revisit the ontology. You can do that within minutes. You don't have to have paid a huge SI, millions, to have moved all your data, then conformed it, and then finally get to the last bit before you actually know whether the thing is going to be of value or not. So very fast iteration. It can be minutes, this process. And once you know, and you've proven it, using those large language models to be able to do that, you can then say, okay, well, let's productionize this. And of course, I'm a huge fan of schema.org, mentioned yesterday, and DCAT, and FIBO, and all of these fabulous ontologies out there that you can leverage. They are already going to accelerate what you do. And there are some tools that even have them embedded. That means that they've done a lot of the research for you. Not to say you have to be constrained by them, but I think they're a great accelerator. Having a standardized meta model like the CDMC information model that's freely available from the EDM Association to download enables you to be able to structure some of the metadata to be able to fulfill best practices. And then when we're productionizing, and this is a sort of data management angle that I like to bring because I am very involved in data management, then you connect to the source having proven the benefit. From an analytic perspective, it can answer your question. So you're now pulling the data with authority. You can apply the data quality requirements to that, but you're fixing the data you need, not just in case some people turn up to use your baseball field. You can create usage contracts. When it doesn't fulfill the requirements, you can fix at source, and you deploy measurements to keep it clean. And then you can operationalize and optimize. For example, you could virtualize the entire top row and then realize we're going to need this all the time, and we need it to be highly performant. So perhaps we'll architect it in a way where we're using cached memory, or we're actually moving the data now rather than virtualizing it, because there might be an efficiency save associated with it. But it's done from an informed perspective. We know this is useful. It's already creating value. Now let's optimize off the top of it. And the semantic approach provides you the flexibility to be able to do that. So I'm going to quickly sum up. And just as Zach said, I'm here all day, so I'd really love to. I hope I've said something at least slightly controversial that somebody would challenge me about, because otherwise, and I hope, for those who are very familiar with these technologies, I hope these are interesting ways of describing it, if not entirely new, and that you can be an ambassador with me to bring the world into a better place. So in short, don't believe the hype. Well, yes, maybe a little. But let's temper the hype with some common sense. What we learned from robotic process automation, what we know about semantics that have been proven over many years and are getting easier and easier to use and adopt. So think in terms of agents, and how do we empower those agents as we would a human being, but also use MCP cautiously. It really is a promising technology. I really do believe, particularly in line with Metcalfe's law, that it is going to open up incredible benefits, but only if we're smart about it, or else we're going to create networks of incredibly dangerous and potentially compromised AI. I dare say that Geoffrey Hinton, who's done an awful lot for the industry, is wrong when he doesn't understand that symbolic AI is important. And I do absolutely bow to his intellect, but he's absolutely limited by the people who learnt how to do quality typewriting. Embrace multimodal AI. It's evolutionary. Why would you stop at one modality? So absolutely combine semantics with large language models, and you will exceed his wildest dreams. And hopefully, he can continue to still be the godfather of AI, but a better AI, one that doesn't fail 95% of the time. Metadata is a graph. When you're doing data management, if you're not thinking in terms of graphs, you're already failing. And that's where the data management industry has fallen over for so long. So hopefully that's a useful takeaway. And then the other thing is, think in terms of flexibility, not brittle architecture. When we're still stuck in the view that we must have the full data model in most technological implementations before we can do anything, that stops iteration, it stops learning, and it really builds a very inflexible way of working. We're smarter than that. We've got better technologies. We've got better approaches. So let's embrace those and help them work for us rather than working for a series of lists or third normal form sort of constructs that work for computers or only a limited number of computers. We can create a more flexible and better world that works for us, like George Bernard Shaw's quote. Let's be a little bit more unreasonable. And with that, I'd just like to say a massive thank you for inviting me to speak. I hope what I've said was useful. I hope some of those analogies can benefit you in what you do. And thank you very much for your time.